Hello everyone, so in this video let us talk about a very important concept which you have to learn while understanding Go concurrency, and that is channels. So channel is a very fundamental concept, so stay focused on this particular video. We'll go through different concepts, different edge cases, what channels are, how we can use them and so on. So let us understand about channels first. So channel in Go provides a way for Go routines to communicate and synchronize with each other. That's a pretty much simple definition. Now, how you can visualize what channels are. So if you want different Go routines, we have talked about Go routines in the previous videos, so you can check out that. So if you want to spawn a Go routine, let's say there's a Go routine like this that is going from top to bottom. The top to bottom, I means that there are different codes. The main function, this is the main Go routine. And we have started the main Go routine. It is going from top to bottom, reading the code like this. Now at some point, there's another Go routine that has been spawned here. So another Go routine has been spawned like this. That is going from top to bottom. Now, if this Go routine that has been spawned from the main Go routine, let's say this is the main Go routine that has been spawned. This is some another Go routine that has been spawned. Now that is being used to calculate some another value, and then it has to pass that value that it has calculated to the main Go routine so that it can communicate, like commute and like do some calculation and then give you the final result. So this second Go routine should calculate and pass the value from this Go routine to the actual main Go routine, or maybe two Go routines have to communicate. Then there has to be some sort of a channel in between them, and that is what channel is. That is used to communicate between different Go routines. Pretty much simple. They have to synchronize. That synchronize means that one Go routine should not like terminate before the other one is giving the values and so on. So this is some sort of a channel that has been used to send the values and receive the values from the other end for two Go routines to communicate. Okay, now the channels can be of two different types. Don't worry, we'll talk about them more in this particular video as well, but I'm just giving you a very high level overview that there are two types of channels. That is, one is buffered channels and other is unbuffered channels. Now what is the difference? These channels, for a buffered case, has some space in them as well, which means that let's say it can also hold data. So if one Go routine is sending value inside in the channel, and there is no other Go routine which is pulling out of it, it can still hold the data. Okay, got it? So that it can hold it, and when another Go routine will come, it can pull it out. So it has some capacity. You have to give some that this buffer channel has a size of 2, so it can hold two values inside it, two units of values inside it that can be pulled later on. Okay, it can only hold 2. If you try to put and push more than 2, it can give error. The unbuffered means that when a Go routine is there and it is trying to push a value in an unbuffered, there is no space in that. So this Go routine will stop. The Go routine that is going on, it will stop, and it will only proceed when the other Go routine is also present to pull. So this channel will only like get okay when one is pushing and other is pulling. Okay, so for an unbuffered channel to work, one is pushing and other is pulling. So that is how you two can synchronize, because the other one can complete the task first, but that has to wait now because it can only push the value when the other one is ready to pull it out. Okay, so that they can synchronize and take out values, pull it out values and so on. So we'll talk about all the one in codes as well, but that is the overall idea of what buffered channels are, what different type of channels are. We can push it, pull out values, and use to synchronize and communicate between these two Go routines. Okay, so that is the overall idea of what channels are. Let us now move down to different other definitions. So the channel is a type used to send and receive value between two different Go routines. Channels are created using the make function, as you can see here. That's the syntax to create a channel. Okay, with the chan keyword. This is the channel keyword that is used to create a channel of data type integer. Okay, so that's one thing. Now how you can send and receive value. So this is the operator that is used here. Okay, so if you want to send a value inside a channel, it is very much intuitive. You can just syntax that you have a value, you have to send inside the channel. So this is a arrow keyword, the arrow operator, that you have to send the value inside the channel. And this is the, if you want to pull out from the channel, so pull out, or like the channel is like you have to pull out, so channel is pushing out the value, so the value is pushing out from the channel and it can be stored in some variable, whatever you want, and it can be taken out from. That is the syntax for pushing and receiving the value from the channel. Okay, so these are the three things that you have to understand: how to create, push and pull. Okay, now let us talk about different concepts as well, and let us write down some code as well. Let's first write down some code. Okay, so let's create the channel using this syntax. So I'll create a channel like this. Then what you can do is that, let's say I'll push some value inside the channel. Then I pull some value inside the channel and put in some variable. Let's print it out. Can you tell me whether this will work or not? You can pause out this video and try to tell me. The actual answer for this is no, it will not work. Let us also check that. It will give some deadlock error. Yes. Why? Because as you can see, this is the main coroutine that has been spawned here. This is the main coroutine that has been spawned here. It is going like this. It creates a channel. Then it tried to push some value inside the channel. But this channel is an unbuffered channel. Why? Because we haven't mentioned anything, any capacity for this channel. So it's an unbuffered channel. So unbuffered channel, as I've told you, will stop if there is till you actually get a receiver. So a channel is there. You are going in a main coroutine. You try to push a value inside a channel, but you can only push when there's a receiver. But the code actually understand that there is actually no code for receiver. When it is come to here, I actually understand that, okay, there is no actual coroutine that has been spawned later or anything like that, that will pull out this value. This value is in the same code, the same thread. Another thread should pull out value. Okay, another coroutine. But this coroutine can only push, but there is no one that will be able to pull it out. So it will go inside a deadlock that I cannot know what I should do because I'm stop at this point. It will stop its execution at the point because it has to push. But it cannot be pushing, it cannot push because there is no one to pull. So it will pause at this point and it will give you a deadlock. Now how can you solve this out? There are multiple ways, actually two ways actually, which I know actually. So the first one is make it buffered, because in the buffered one I told you that buffered one can store these values as well. It can store the value that has been pushing, so you can push it, you can store it, and then you can pull it out. So pretty much simple. Then let us check this out then. So you can push and pull and then it is working fine. Or else if you want a buffered only, so you have to now create another coroutine. Okay, so you can make an anonymous function. So let's make a function here. This anonymous function will push the value. You can make it a go routine. The anonymous function will push the value and the main coroutine will pull it out. So now the code will understand that, okay, one function called a coroutine is pushing, at the same time the other one is pulling. So that is fine. So that can, and like they will be synchronized with each other. And so for the missed, that's the overall idea that you have to use channels here. So I hope you understand with the code part now. Let's move forward. So sending, receiving, we understood that. Let's talk about that. If you try to push more values in a buffered channels, then it can hold. So let's try to take what is an example. Suppose this is a buffer. So I will talk about blocking. Don't worry. We'll talk about the buffered channel first. Buffered channel, we've understood the definition here. Now, if I try to push more value in a buffer channel like this, let's take this code and I'll here uncomment it, and as you can see, if I try to push in value in a buffered channel which is of size 2, I have tried to push 3 values, then it can hold 1 value, 2 value, but the third value when you're trying to push, there is no one to pull, so it cannot hold that third value. It can hold these 2 values, it cannot hold a third value. So then it will give you an error, deadlock, right? Because it can hold 2 values, but now after a third value, it is like acting like a, you can say, unbuffered channel only, because it doesn't have any value like storage to hold. So it can only hold if there is some receiver that is pulling out some values, and then you can store some other value. You understand the overall idea here. So that is why it is giving to you. So you cannot push in values more than the buffered size. Okay. So now moving down to the buffer channels, we understood that. Now let us talk about the blocking behavior. As I've told you, the channels are blocking. They are waiting on each other. Let's talk about with this code part so that it will become more clear to you. We take this code as a, take this here. So what we are doing here is that we have created a channel like this here. Then we have spawned 2 coroutines. One is pushing the value inside the channel itself, and the other one is pulling. So the code actually knows that there are now two coroutines. Now this coroutine is actually, as you can see, pushing. So it will first send that I am attempting to send. It is trying to push, but it cannot push because there is no receiver. Why? Because let's say the receiver will be spawned after, let's say I'll give you 5 seconds. So this coroutine wants to push the value inside the channel. Okay, so it will first print this. Then when it wants to push the value, it cannot push because there is no receiver. Why? Because when the code move in this direction, this is spawned, then it has to wait for 5 seconds to actually create the new one receiver coroutine. The receiver coroutine will spawn after 5 seconds, but this is actually created before and it is trying to push the value. So if it is trying to push the value, it cannot go to the end because it will block at this state. So it will block at this state. It is like synchronized with this one, so it has to wait for some time. Now when this coroutine will get promoted, or like when it will get spawned up, this will then pull the value and then it will like push the value and then it will come. So let us look at the code execution only, then it will become more clear. So as you can see here, it is stopped at attempting to send. It's stopped for 5 seconds. Then attempting to send is stopped for 5 seconds because it is stopped, or its execution, this coroutine has stopped at this particular point, as you've seen. Then it has wait for 5 seconds. Then this coroutine is spawned after 5 seconds, which send now attempting to receive. Now this coroutine has started, which will now start pulling. And when it start pulling, it will send it, it will receive it, and then it will print the value. And then when it is done, it will send that, okay, value is sent to the channel, and it is sent that value is received from the channel. So it is done in a synchronized manner. How? Due to the help of unbuffered channel. Okay, so that is the use of unbuffered channel to synchronize these two coroutines to send and to receive the values and printing out and then the program. Okay, that is the very good example of how you can synchronize these two coroutines using. That is also done. Now moving down to the last point of channels. So we have talked about how you can create them, how you can spawn different channels, how you can synchronize between them, how you can interact between them, how you can like pass value from one coroutine to another, and so on. Now after all those stuffs, you have to close the channels because channels have remain open. As you can see, in an unbuffered channel, the other coroutine can be paused, it can hold, it can still be like I can get a value, I can get a value, it can like go in an infinite loop as well. So you have to close the channel also to mark that you should not push any value more. So if you close a channel, you cannot now not push any more values inside the channel because it is closed. Okay, so you have to close the channel as well. So it is about to close channel when it is no longer needed to signal that there is no more value that will be sent. Closing a channel is done using the close function. We'll tell you how. And important, once a channel is closed, any further attempts to send data in that particular channel will give you panic. If you try to push any more value after the channel is closed, it will give you a panic. And attempting to receive a value after the channel is closed will give you 0 values or like empty strings. So see, if you try to send a value in a closed channel, it will give you panic, but you can receive values from the channel, like there is no error, but you will get empty values or like null values. Got a point? Because there is nothing, you can still pull values, but it is actually 0 or empty strings or null values. Okay, so how you can pause it out, you can just say that I've created a channel, you have created, you can say a coroutine, and when we are pushing the value inside the channel, we don't want to push anything more, we will be defer and close the channel. This is the close keyword, that is close the channel with the channel name, and now it is closed. Defer means that it will be closed after this whole function call is done, and it will close the channel so that no more values can be more pushed inside the channel. Okay, so that is the overall thing that you have to also understand, that how you can push, and this is a very important point, that if you try to more pull, what will happen. Now the directions of channel, whenever you want to create a function call in which you want to send channels, you are creating new functions, that is send data or receive data, you are creating functions for them. If you want to create a function that is sending values inside the channel, so you have to create like this, that a value is being sent to the channel, and this is the value that is being extracted out from channel. So pretty much simple syntaxes to send a value. You can also make it like this as well, nothing much problem that will cause here. You can also like make it like this as well, channels. Okay, the only thing is that it's better that you mentioned that the channel is receiving or sending for the other person who is reviewing your code, to make it much more easily readable. It's a more good convention, but you can also name it as channel as well. And the other thing is, yeah, channel direction we have talked about. So this is the channel direction, that's the third 6 point, and that's it. That's the overall idea that you have to learn about channels. No more code, that's it. You have talked about a lot of codes in this video. So channels are a very powerful mechanism to coordinate and execute between concurrent parts in code. They promote clean, idiomatic, concurrency pattern and help avoid race conditions, okay, by providing few safe rules to share data between these coroutines. Understanding and mastering channels is essential for effective concurrent programming. So that's the overall idea and the code part for understanding channels in Go. If you still have any doubts, you can mention it in the comment box for this particular video. I will see you in the next one. Till I keep coding and bye.